Hi and welcome to this quick how-to help video on finding the surface area of a cylinder. Now this is a topic that can take a little while to click into place, so hopefully the video will be really useful and help you make sense of all the separate elements of what we need to do to work this out. So the surface area, as we know, is the entire surface. Now we've got a circle at the top and at the bottom. Now that's fairly straightforward. The area for a circle is pi r squared, and most students are fine cracking on with that part of it. But it's the curved surface that causes a lot of trouble, okay? So we're going to try and explain how the curved surface kind of unfolds, okay? So let's first of all start by looking at the top. So we're looking at the circumference around the top of the cylinder, and I'm going to do that with a little kind of dashed line. That's the circumference, okay, which we know is pi d. Now, if the circumference was made from a piece of string, I could kind of start to unravel it, couldn't I? And let's kind of try and depict that. That would be me breaking it away, and I'm just starting to unwind it. The piece of string was pi d when it was in a circle. If I just break it apart a little bit, it's still the same length. It's still the same piece of string. It's still pi d. Remember that pi d is just a value. It's a number, okay? If d was 2, then pi d would be 6.28 to 2 decimal places. So that would be the number. And as the string unfolded, it would still be 6.28, wouldn't it? Okay. Eventually, I could unravel that string into a straight line. It's still the same length, so it is still pi d. This length here is the height of my cylinder. So when I unravel the curved surface, it turns into a rectangle where the top is the circumference, so it's pi d, and the side is the height of the cylinder. And that's what we need to use when we are working out. All right. So if we look at the net quickly, we've got the circle at the top. We've got the circle at the bottom. And then we've got the curved surface here, which has pi d, the circumference, as one edge and the height as the other. And it's those elements that we're going to be using to solve the problem. So let's just keep that as a kind of go-to key. All right, let's put it there. There we go. All right, let's start solving the problem. So we are going to do the area of the top. So the top is pi r squared. So I've got to go to the diagram. There's my circle, and I need r, which is the radius. I'm going to mark it in. I want that. It's not there, not exactly there, but the information I need is down here. So they're telling me that from one side to the other, I have a distance of 6 centimeters. So that is the diameter. So I can see that the diameter is 6, which means the radius is 3. And I really love writing this key because then it's just a go-to. It's a place that I can go and get the information I need to finish off whatever it is I'm doing. So I need 3 for the r. So I've got pi times 3 squared, which is 9 pi. At this stage, I could put it in my calculator and I could get a decimal value. There's nothing wrong with that. Do that if that's kind of your comfortable place. But I would encourage you to just to try not to. If you're working in the decimal, that's fine, but you're going to need to keep at least 4 decimal places, because if you start rounding at this stage, then your final answer might be just slightly off because you've used rounded numbers in your working out. Whereas if I can be comfortable to just leave my answer in terms of pi, that's a perfect number until I go to a decimal and start rounding. Okay, it's a number I can't see, but it's still a perfect number. So if the top is 9 pi, the bottom is 9 pi. All right, so that's those two numbers, because that's what they are. That's those two numbers found. So I could, if I wanted to use my net, just say, right, I've got that and I've got that. Could fill it in. You could say, I know that's 9 pi, I know that's 9 pi. All right, whatever works for you. Now we're on to our curved surface. It's a rectangle. So I know that the area of a rectangle is base times height. If I go over to my net now, I can see that the base is pi d. So I need to do pi d times by the height. Okay. And then I start the maths. So I'm going to go over to this diagram to find the information I need. So I need the d. I've already done a key for that. D is 6. So I'm going to be doing pi times 6 times the height, which is here, 5. That's going to give me 30 pi. So I now know that this bit equals 30 pi. So my total surface area is equal to 9 pi plus another 9 pi plus 30 pi's. This is like collecting like terms. I've got a total of 48 pi's. At this stage, I am going to stick it in the calculator, and that's when I get my answer as a decimal. I'm going to round it to one decimal place, and the answer is 150.8. And its surface area, so centimeters squared. And that's it, the surface area of a cylinder. And every cylinder works in the same way. Now, your height might not be as obvious if they draw, and this is just going to be freehand, so it won't be beautiful. But if I was to draw it this way, so I've got it like that, then obviously it's like they've taken the cylinder and they've dropped it on its side. So the height going straight up is now a height going back. So just be mindful that that is still a height at the end of the day. Okay, that's it. That is surface area of a cylinder. All right, good luck with this topic. Hopefully it will go well for you. And I will hopefully see you in another video soon.